All right, guys, tonight's special guest speaker, Dr. Ellen Preger, is a marine scientist and author with an incredible knack for making science entertaining and understandable. She holds a master's degree from the University of Miami and a PhD from Louisiana State University. During her career, Dr. Preger's worn a lot of different hats, including researcher, educator, consultant, scientific advisor, and public speaker. She was previously the chief scientist at the Aquarius Reef Base. This is an underwater laboratory down in the Florida Keys. She was also the assistant dean of the University of Miami's Rosenstiel School of Marine and Atmospheric Science. She's appeared on the Today Show, NBC News, Good Morning America, Fox News, CNN, the Discovery Channel, and the Weather Channel, and she was a consultant for Disney's movie Moana. I thought that was really cool. Dr. Preger's written a number of public-oriented science books, both for children and adults, including the inspiration for tonight's lecture, the book Sex, Drugs, and Sea Slime, The Ocean's Oddest Creatures and Why They Matter. Following Dr. Preger's lecture tonight, there will be a book sale and book signing right outside of these doors, if any of you are interested in picking up one of her books. It is with great pleasure that I introduce Dr. Ellen Preger.
Nope, there it is. Yes? Okay, great. Well, first I want to thank Zach for inviting me and the Florida Coastal Center and Oceanographic Society. I went over and saw the site today, and they are doing such good work, and it's so important to support local organizations like what they're doing here. So thank you so much, Zach, for inviting me, but also for what you're doing for the local community and this area. It's really very important. So I always like to begin a little bit with my checkered past, as Zach said. I've had a lot of different jobs, and you know, I also call it my unexpected career path, because I really thought when I got my degree I would be your typical researcher, teaching, and that was great. But somehow I ended up doing some really kind of different types of things. So as Zach mentioned, I was the chief scientist for the world's only undersea research station in the Florida Keys, and that's shown here, Aquarius Reef Base. And while I was there, I got to do 2 missions living underwater for 2 weeks to study coral reefs. So it's fabulous unless you're claustrophobic. Then maybe not for you. I loved it. I'd go back anytime. I also taught oceanography out at sea with Sea Education Association, where we would spend 6 weeks onshore with our undergraduates, and then we would take them out to sea on a tall sailing ship for 6 weeks at a time, which was fantastic. Somehow, I have become one of the go-to people when things happen with regard to the oceans, so that CNN and NBC calls me, but it's, you know, I always say to them, can't you guys call me when something good happens? I've become like the disaster diva. It's tsunamis, you know, plane crashes in the ocean. It's like, no, something good, come on. That doesn't work. And then, of course, I think probably what will be the pinnacle of my career is when Disney called and said, would you be a consultant for Moana? It was so much fun. I got to go out to the studio and give a talk to all the animators and the producers and everybody, and it was really fun. I got to talk to them about what should the ocean look like in the movie? What are the different characteristics that they can portray? And they didn't know a lot about the oceans. And so there were some simple words that I used that they'd be like, what is that? And then when the movie came out, there's a line in the movie where it says, there was a fish kill on the lee side of the island. And I was like, yes, that came from my lecture. So, and it was funny, my sister saw the movie before I did, and she stayed, you know, after the movie's over and the cleaning guys are coming through, and she's got her camera out. She's like, probably not supposed to do this. And she took a picture of the credits, and I was so excited. So of course I had to do the same thing. But what I really liked about that experience was combining science with these creative minds and being able to talk about how can you depict science in a way that is not only as accurate as possible, but makes it entertaining as well. And that's been sort of one of my focus areas. So, another unexpected career path has been writing books. Again, it's not something that I really imagined myself doing, but I I started writing children's books and popular science and just discovered I love communicating science to non-scientists and making it fun and understandable. And so, in addition to popular science, I've also written children's illustrated books and also an adventure series for middle graders that combines science with sarcastic humor, which I think you will discover is something I completely enjoy, and a good villain and adventure. And I'll talk more about my latest one in that at the end. So, of course, I have to say something about the title. I should say that wasn't the original title. When I sold the book to Chicago Press, which is kind of a scholarly press, it was something like Weird and Wild Under the Sea and Why These Creatures Matter. But as I started doing research for the book, I discovered that there are a lot of, shall we say, interesting reproductive strategies to bring forth the next generation. Okay, there's some kinky sex going on under the sea. Turns out that pharmaceutical discovery is huge in the ocean. And in fact, more marine organisms are being used in the search for drugs or as biomedical research models than I ever imagined. So drugs. And then it turns out it is very efficient to use mucus in some way under the sea, whether you're capturing food, deterring predators, or traveling. Okay, it's very slimy under the ocean too. So I proposed to my editor, I've got a brand new title. And at first she was like, I don't know about this, but I think it has grabbed some people's attention that might not necessarily have read the book. So they like it after that. But before I go on and share with you some of my favorite stories from the book, I must have a little warning. Viewer discretion is advised, undersea animal nudity, and explicit reproductive language. Just saying. So the first chapter in the book is called The Invisible Crowd, and it really focuses on the microscopic domain in the ocean, the things that we can't necessarily see, but are very important. This is a picture taken from a microscope looking at what could be in a drop of water. And here you see some phytoplankton, which are the drifting plants, and zooplankton, which are the drifting animals. And there are some beautiful designs. There are some sort of monsters, albeit in miniature, and even slime in the microscopic domain. And in some places, in a teaspoon of water, you could have more than 1 million organisms. So when somebody says close your mouth when you get in the ocean, it's not just to hold your breath, unless you would like more protein, to keep out some of these critters. This is one of my favorite images. One of the things I did with this book is everybody said, oh, you're not going to just have like pretty dolphin jumping pictures. And I said, oh, no. I must find fabulous pictures to go with the title. But this is a beautiful image of a foraminifera. Anybody heard of a foraminifera out in the audience? Anybody heard that? Oh, you poor people. So a foraminifera is an amoeba-like creature that lives in a shell, shown here, and they can be, some of them are disc-shaped and they live on the bottom, but this is a kind of foraminifera that lives floating in the water all the time, and they live in these tiny, it looks like a cluster of golf ball shells made of calcium carbonate, and this amoeba-like creature lives inside, and to feed, he's floating around, he sticks out his arms of mucus or slime, and he captures bacteria and particles going by, and that's how they feed. But this is a really beautiful picture because the live foraminifera, usually you just see their dead shells, and you'll see it also has spines of calcium carbonate, and that helps keep it afloat in the water. But what's also unusual about this is look at all those dots on the spines. Can anybody in the audience guess what they might be? Just wild guesses, shout it out. Slime, it could be slime, but it's not. Stingers, eggs, these are all excellent guesses, but no. They are actually algae cells. And what this foraminifera does is in the morning, it has these algae cells inside its shell. It pulls them out with its arms of goo, puts them on the spines to photosynthesize and grow in the sun, and then at dusk, it pulls them back into its shell. And that way, if there's not a lot of particulate matter floating by, they have their own little farm inside. It's very clever, especially since they don't have a brain. Now, a lot of the creatures that we see in the microscopic world in the ocean are larvae, or the babies of things that when they grow up, we would all recognize. But when they're larvae, I like to call them mystery young. So we're going to play a little game where I will show you the larvae of some creature, and I want you to guess what it is, and then I'll show you what the adult picture is. And I just want to say, any biologist may not play because that's kind of like cheating. I know there's a couple. No, Zach, you're cut off. So this is not a Pac-Man. It is the larvae of something that you would recognize after it goes through several changes and stages. Any guesses? Lobster is a good guess. No. Shrimp? No. Oh, I heard it. It is a crab. Okay, how about this one? I bet somebody knows this one. I think I heard it. It is a lobster. That's right, a lobster. Okay, this one is pretty tricky. This one gets a lot of people. Any guesses? Sir, it has to be in the ocean. Any guesses? Squid is, everybody guesses. Squid is a great guess, but no. Octopus, no. Samfleet, it is, you ready? Sea star. Oh, see, that's always, oh. Very cool. Okay, this one's easy, and you can't just say fish. No, that doesn't cut it. Anybody know? I heard, Zach, I know you're just dying to say. It is a flounder, but if you notice, there's something really unusual. Notice that in its larvae state, it has an eye on each side of its head. And as it grows, one eye migrates over the top of its head, and it lies down on the blind side. And different species, the eyes migrate in different ways. And plus, they get rid of this funky little headdress right there. So I'm telling you, there's weird stuff going on under there. Well, this is not microscopic in the sense that you can't see it. These are called euphausids or krill, and these are big enough to see with the naked eye, but I wanted to put them in there because they're so important. These are like the protein drink of the sea. Birds, seals, fish, whales, all over the world rely on eating krill. Well, why do they matter? One of the things I did in this book is at the back of every chapter, there's a section called Why They Matter, not only to the ocean ecosystem, but to human society as well. And we think of, why should you care about the lowly plankton? Well, how many of you like to eat fish? I'm going to raise my hand. I like to eat fish. If you like to eat fish, then you love plankton. Because at some stage in their life cycle, almost every single fish eats plankton. So if you're eating fish, you're eating plankton. Turns out now, fish are also becoming very important in health products, or plankton. For instance, this Mega Red is made with krill. There are face creams made with compounds that come from planktonic organisms. And in fact, there's a really interesting compound that causes blood clotting, and it comes from the exoskeleton of crabs and things. And they're now using it in trauma and military operations because you can have a bandage with that compound on it, and it promotes blood clotting. So there's all sorts of interesting things happen. But so plankton are very important, and we should care about the plankton. Another chapter. Mega slimes, seductive shapeshifters. Starting with the lovely hagfish. These are not eels. These are actually bony fish, but they look like eels. They are, scaleless, jawless, finless, and they tend to live in cold, salty water. In the Gulf of Maine, there's hundreds of thousands of hagfish. But the hagfish have a little problem. They don't have a jaw. And so to get to the tasty insides of their prey, they only have some teeth on their tongue. Doesn't really work very well. So they have to find other ways to getting inside. So they tend to go in through the mouth of their prey, through the gills, and I'm sorry to say, the back door. And I got the idea to sort of use these wacky creature stories from a friend of mine who lives in Maine, and we were going out hiking. We were on a boat through the Gulf of Maine, and she said, I am not going swimming anymore in the Gulf of Maine. I'm like, why not? She said, hagfish. So you don't have to worry. They really only go after dead and dying things. So when a whale falls down, hagfish. But you swimming, not so much a problem. Although there was this one triathlete in Maine who said he wears a wetsuit not because it's cold, but because there's that sneaky orifice-seeking hagfish. It makes him swim faster. The hagfish is also known as the slime monster, or sea they're threatened or injured, they have the capability to produce copious amounts of mucus very quickly. So they can fill something like 7 buckets with slime in 2 minutes. And here you see a researcher holding a hagfish, and there's the mucus, the lovely slime. But there's a problem. The hagfish is not immune to their own slime. And so they have found ways so they don't suffocate in it. It out their nose, or they're very flexible, and they can actually wrap their tail around their body and then move the knot up towards the head and essentially squeegee off the slime. Hagfish are very important in the ocean ecosystem. They're the kind of the cleanup crew. Anything falls to the bottom, they'll clean it up. Medical research is very interesting because they feed on dead and dying things, and they have a primitive immune system, but they don't get sick. So they're very interesting in that way. There's a guy who's trying to use, by now he might have succeeded, to use the mucus to create biodegradable material to make clothes out of the hagfish slime. Maybe not. And some places where they put them on a stick and roast them. No. I will say one thing. I'm willing to go swimming in the Gulf of Maine, but burial out at sea is over for me. No. The lovely sea cucumber. It looks so docile and friendly, and what could be strange about the sea cucumber? How many of you have seen cucumbers out there snorkeling or scuba diving? Right? Honestly, they kind of look like big poops on the bottom. They don't look very active. A lot of them sieve sediments through their gut, and they take the organic matter out. Some of them, they suck up the sediments, and they take the organic matter out. Some of them have tentacles, and they filter the water column. But they also have some sci-fi capabilities. If they're threatened, their kind of leathery skin, they can turn it into a slimy, gelatinous goo. And if a predator approaches them and is very threatening, they also do what's called eviscerate, meaning they basically puke up their internal organs and crawl away. Now, that would be like if a mugger came up to you and you vomited up your lungs and said, "See you later." Not so good for us, but amazingly, they can regenerate their internal organs within 3 to 5 weeks. And you can imagine that is something, again, that medical experts are very interested in. Okay, you guys, I can tell you're going to like this story. I don't always tell this one, but I think you're the right kind of audience for it. So when I was doing this research for this book, I went into a lot of early journals, I talked to a lot of my colleagues, and I was in a class of graduate students, and I said, okay, what do you think is the weirdest creature or the weirdest thing you've learned about in graduate school? And people are like, the pearlfish. I'm like, I don't know what the pearlfish is. The pearlfish, it turns out, has a special affinity for sea cucumbers. They're these little tiny fish that during the night, they're out on reefs, feeding, doing whatever fish do at reefs during night. And then the day, they need a place to hide from predators. They have developed a way to detect the excurrent or outcurrent from the sea cucumber. And so they swim around, they say, oh, I detect a sea cucumber, swim towards it. They swim up the butt of the sea cucumber and hide out during the day inside the sea cucumber, nibbling on its internal organs. Well, turns out the sea cucumbers don't really like this very much, as you can imagine. So one species of sea cucumber has actually evolved a teeth-lined butt to prevent the pearlfish from going up there. Who knew? So sea cucumbers are also part of the cleanup crew. Biomedical research are very interested. And of course, in some places, they also eat sea cucumber. Anybody here eating sea cucumber? I don't see many takers. Yes? Thumb up or thumb down? Up or down? Up. I get it. We got a thumbs up. Excellent. Oh, another one of my favorites. Everybody here must be familiar with the queen conch, right? Well, I have a colleague, Al Stoner, who's a fisheries biologist, who's been studying the queen conch for years. And so I sent him an email. I said, Al, do you have any funny stories about the queen conch? And oh, to my delight, he sent me back a note that said, Well, there's a real advantage to studying the reproductive biology of an animal that is big, slow, mates for hours on end, and has a penis half its total body length. Who knew that the male queen conch was so well endowed? Well, in fact, the biologists have been writing limericks about the male queen conch, and they call it the verge. The verge, they've been writing about the verge. So this is why I had to warn you earlier about my images. There is a male queen conch extending or thrusting his verge to the females. But imagine, you can sort of imagine why they have to do this. So the male queen conch slides up, crawls up to the female, and he has to get his verge out from under his shell and around and under the female. So it kind of has to be sort of long. But there's a little problem. When the verge is outside the shell, crabs and eels are only too happy. But men, don't worry. Lose one, they can grow another. Yes, who knew that the male queen conch can regenerate his penis? Has anybody here ever tried to clean a conch out of its shell? They are what? Very slimy, right? The friends of the slime. Yep. More snails. So there's also a snail in the ocean that spends its entire time swimming. They're not on the bottom. The foot that we think of as a snail crawling around on has actually been modified into these two wing-like fins, and they're called pteropods or sea butterflies. And there's a shelled variety or the naked variety, and those are the two fins. That's the foot has been modified, and so they spend their entire time in the water column. The naked variety, and they're very plentiful. The shelled varieties have been called sort of the potato chip of the sea for other animals and like fish. The naked variety has an interesting reproductive strategy. Some of the species they all start as males. They mate, swap sperm, and then they change body parts into females. No gender problems, relationship issues. It's fantastic. The cone snail is a really interesting organism. There are something like 700 species of cone snails. Some have very weak venom. Some, one nick and you're dead. So you have to know which kind you're picking up. Scientists think that of all the animals in the world, they have the most potential for pharmaceutical development. And one reason is that some species, like this one shown here, will hunt fish. And what they'll do is they'll bury themselves in the sand, and they have a little siphon that goes up that can detect chemicals in the water. Fish will be swimming by, and as the fish swims by, they shoot a harpoon-like tooth out at the fish, and it's on a tether, so they start reeling it in, and then their snout can extend like a snake over the fish, and in the harpoon-like tooth is venom. If that first strike doesn't work to paralyze the fish or weaken it, they actually can change the chemistry of their venom and strike again. And so the ability to change the chemistry of their venom is incredibly rare in the animal kingdom. And there's already a drug out there on the market called Prialt that is a painkiller derived from the venom of a cone snail. And for people who are addicted or allergic to opiate-derived drugs, they can take this one because it comes from cone snail venom. Some more of the snails. There are the nudibranchs. And the nudibranchs are essentially they're snails without shells, and nudibranch is for naked gill. And see this little thing out here? That's its gill on the back. And I know it's the back because this is the front, and it looks like those are ears, but those are what are called rhinophores, and that's where they detect chemicals, or that's sort of their nose. And just so you know, this one, so that's the back and that's the front. These are some clown nudibranchs. There's a little action going on there because they always do it head to tail. This is a nudibranch laying its eggs, and it kind of looks like frosting coming out of a tube or something, but that's a nudibranch. What do you think its common name is? What does it look like? Fried egg nudibranch. And those are its eggs, and they often put them in very bright colors, because many things that are bright colors are toxic in the ocean. And so even if the eggs aren't toxic, it's kind of a bluff, so that things won't eat it. But if you ever, I like to think of these as the undersea bling. The nudibranchs have amazing colors, patterns, textures. These are all different kinds of nudibranchs. A related organism is the sea hare, and they have the ability to eject ink as a smokescreen or a decoy for predation. They also have a very simple and large nervous system, and scientists have been using them all over the world to study nerves and the nervous system. And these are two very special kind of nudibranchs. They actually, when they eat, they suck the chloroplast, or the cells containing chlorophyll, from their prey, from algae. They suck those up, they don't break up the cells, and they use them in their body like solar power. So they keep the chloroplasts whole, and they use them in their body photosynthesizing, and it helps them grow. So one of the areas that I did my research in when I do work in research or studies in the ocean were coral reefs. So I had to put a couple coral reef things in here. This is a wonderful image of a brain coral during the day and at night. How many of you are scuba divers? I always love to see how many snorkelers? Excellent. Well, we've got a lot. Well, if you ever have a chance to go out on a reef at night, it looks incredibly different. So here's the coral during the day, and here's the coral at night, because most corals, not all, but most corals are actually colonies of small creatures called coral polyps, which is essentially a ring of tentacles around a stomach, and they come out at night to feed on plankton. And here's a great close-up of a coral polyp, a colony on a coral, and look at this one has caught a fireworm. So that's what a coral close-up looks like. Now, in addition to having tentacles like this, some corals, not all, have something really special called mesenterial filaments. That's kind of a mouthful. They're really cool. So here's a picture of a coral, and see, it almost looks like angel hair pasta coming out of it. Those are its mesenterial filaments, and they're little tiny tubes that are connected to their stomach. So corals grow pretty slowly, and so they don't want things overgrowing them. So the really slow-growing corals will take those mesenterial filaments, and they'll go out, and if something starts to encroach them, they'll send those filaments out, and they'll eject digestive enzymes from its stomach out and create a kill zone around them so that they can keep growing. So since it comes, the enzymes come from the stomach, it's a gut reaction. Hey, if you laughed at Zach C., I figured I had a good crowd. So one of the things that we've discovered with these mesenterial filaments is that one of the ways that you can have fast-growing corals, which are the branching corals, coexisting with slower-growing corals, the head corals, is because the head corals are very aggressive with those mesenterial filaments. And so that's one way you get the corals growing together. Even if some grow faster than the others, they don't grow over them because they get attacked by those mesenterial filaments. Coral reefs, everybody thinks of sponges as being, there's nothing going on. They see a sponge, it's not doing anything. Well, some colleagues of mine did some experiments with this dye called fluorescein, and they're showing you how actively sponges pump on a reef. So sponges are filtering water. That's how they live. They filter organic matter from the seawater. They bring it around the outside of the sponge, and then it comes out through other holes or osculums, and that's how they filter seawater. Well, it turns out a big barrel sponge like this can filter the equivalent of an Olympic-sized swimming pool in just a couple days. And so that should tell you just how active these are pumping on the reefs. And it turns out scientists are studying how they're changing the chemistry on the water of the reef because they are so active. Yeah, you don't see that, right? When you're out diving and snorkeling, you don't see that it doesn't look like there's that much water flow going on. So a couple other residents on the reef. Everybody must know this one. Moray eel, right? Well, moray eels don't have scales, so they are friends of what? Slime. Their bodies are coated with mucus for protection. Anybody know what kind of fish this is? I think I heard somebody say it. It is a jawfish, and the way I know it, I know it's a male, because the male jawfish incubates its eggs in its mouth. And they will periodically spit them out, rotate them around, and then pull them back in. This is one of my favorite images from a colleague of mine. This is a parrotfish sleeping on a reef. Now, not all parrotfish do this, but some species of parrotfish at night will find a hole or a crevice in a reef, and they'll sleep. But to protect themselves, they spin a cocoon of slime. Thank you very much. Yes. So here you see it coming out of its mouth, and he has spun a cocoon of mucus around himself. And there's 3 theories about this mucus. One is that it's toxic to anything that might eat it. 2 is that it masks their smell from predators. And the other one is that it might protect them from parasites while they're sleeping. Or it could be all 3. We just don't really know. So one of the things that I talk a little bit about the book is sort of economics. And it turns out, if you look at all the services that coral reefs provide in tourism, revenue, fisheries, they are essentially worth $1 trillion per year. And when we think of banks and the insurance industry too big to fail, I always like to say we need to think of the ocean and coral reefs as too big to fail. We need to protect them. Another chapter is called Armed and Dangerous, and I love this sequence from Roger Hanlon in Woods Hole, who he's been studying cephalopods and octopus for a very long time, and what he can show you is that they are the best camouflage artists on the planet. But what's also fascinating is that he's discovered that he thinks most of them are colorblind. Now, exactly, you should be saying, how do they match the color if they're colorblind? He thinks that they have color sensing capability in their skin. So who do you think is funding his research? Ooh, that would be good. The military. Imagine if you had wetsuits or tanks or underwater vehicles that could sense the color around them and match it. Personally, Harry Potter's invisibility cloak. So this is a very special octopus called, well, we're going to talk about the blanket octopus, but in general, reproduction in octopuses, it's pretty simple. The male sidles up to the female, and he has one specialized arm, and he takes a package of sperm from his body and gives it to the female. No snuggling, no foreplay. Take the sperm, you're done. And that's why I call it the baby maker arm. But in the blanket octopus, it's a little different. And this is, as I said, a very unusual octopus. There are its arms, and they've got this webbing, and they spend a lot of their time actually up in the water column. And this picture was taken in Key Largo, actually in Florida. But when the male sidles up to the female and gives her the package of sperm, he actually self-amputates his arm and gives her that as well. Oh, such self-sacrifice. But then, when they find the females, and then I should say, after that, he dies. But they find females with multiple male arms in her body. So, when I was writing the book, there was only one word that my editor would not let me use. And I will just share this with you, since I couldn't write it. So I called the female blanket octopus a slut. So instead, I had to say that she swims around. Cephalopods, squid, octopus are very important in biomedical research. Squid have very large eyes and nervous systems, and they're being used for biomedical research. It was funny, when I wrote this book, I thought back, 20 years ago, how often did you see calamari on the menu? Not much, but now it's on every menu. And they live fast and die young, and so it's a pretty sustainable seafood. So the cephalopods are also very important in food and jobs. Some more. So sea stars. Sea stars can have up to 14 arms, and one of the really interesting things about sea stars, most people know that if they break off an arm, they can just grow another one. But it turns out, if when the arm breaks off, it takes some of the central disc with it, they can grow a new body, because there are replicate parts inside that little disc. And I always think of it as, those bad B movies where there's a hand going along the scene, sea star, growing body. Box jellies, these are the box jellies like sea wasps and some others. These are some of the most venomous jellyfish in the ocean, but they're also very interesting. So they're called box jellies because they have 4 sides. And one thing that's interesting is you look at that dot right there, it turns out those are a set of 6 eyes. So they have 24 eyes. And they can't really see, but we think that they have some sort of a blurry image so that they can avoid obstacles and go towards prey. But what's fascinating about that is, so if they have eyes, they don't have brains. So how are they processing the images? We don't know. Another chapter is the Cabinet of Curiosity. Just kind of the weird fish that's out there. This is called the barrel-eye fish, and it lives in the twilight zone. And everybody thinks that those are its eyes, but in fact, those are its eyes. Because if you live in the twilight zone, you want to look for most of your food is probably above you, as well as predators. We don't really know what those things are. It's one of those fish that we don't have a chance to study very often. That's a pine cone or a pineapple fish. And anybody know what kind of sharks those are? They are called cookie cutter sharks. And the way they feed is they can actually rotate around their jaws, and they will actually sort of bite onto something, rotate around their jaws, and they pull out a plug of skin. So they're called cookie cutters. Now, they tend to be very small. And years ago, somebody said, oh my gosh, now is this something else I have to worry about? Cookie cutter shark. I said, oh, no. Don't worry about that. But it turns out there is one deep water trench in Hawaii where people swim. I'm not sure why. People swim, and there have been a couple of cookie cutter attacks. But that is the only place in the world I've ever heard of that happening, so don't worry. Here are just some cool pictures. That is a pygmy seahorse. And this is a frogfish, and they are kind of like the masters of Zen of the ocean. They sit on the bottom, and they wait for something to come and potentially eat what they think is a little lure or, a dangling piece of plankton or something. So there's the pectoral fins, there's the eye, there's the mouth, and again, the dorsal fin has been modified into essentially a fishing lure. One of the things that we've discovered in the ocean is that even in the most extreme environments, animals don't just live, they flourish. And this is a Greenland shark from the Arctic. They live in the Arctic. During the summer months, they actually live fairly deep. During the winter, they can come up to the ice edge. We think they can live maybe even more than 200 years. They might be 20 feet long. But what's really interesting about the Greenland shark, we don't know very much about them, but for the ones that have been caught, in their stomachs, well, I should say, we think that because they live in such cold water, their metabolism is very slow and they're sort of like zombies. But in their stomachs, when they've been caught, they found other sharks, halibut, seabirds, reindeers, and a dog. All I can imagine is that, at the winter's edge, it's winter and there's some reindeer doing this over the ice edge, right? And it's like, ooh. But we don't know much. There is a theory that they often have a parasitic copepod that hangs off its eye. Some people think that might attract other things like a lure, and that's how they eat them. But again, it's just one of those animals that we just don't know very much about. My favorite name. Bone-eating zombie snotworms. I need to use that in one of my books, my kids' books. So these are tube worms. They were just discovered in 2004 in Monterey Bay, and they live on dead whale bones. So this is a colony of tube worms living on a dead whale bone, and this is the worm itself, and these kind of roots are jam-packed with bacteria, and that bacteria digest fat and oil in the bones, and that's how they live. And so that's why they're called zombie. And they're called zombie snotworms because if you disturb them, they release a lot of goo, a lot of slime. But one of the interesting things here is that scientists are looking at that bacteria, because they digest fat and oil, to create the next super detergent, which is pretty interesting. So my overall message with this book is that no matter how big, small, or incredibly bizarre the animals in the ocean are, they're very important to the ocean ecosystem, but also to human society as well, for food, jobs, biomedical research and health, inspiring wonder and creativity. But of course, so many of the animals are at risk today, because who is the ocean's most fearsome predator ever? We are. So, as you heard, I actually do quite a bit with the media. And I always get asked this question, what is the worst problem in the ocean? Well, instead of me telling you what, I don't really think there's the worst problem in the ocean. I like to say I have my top 5, okay? I have my top 5 problems. And so instead of me telling you, we're going to see if you can guess what my top 5 problems in the ocean are. So let's see some hands. Plastic. Okay, I'm going to put plastic under pollution. Ding, ding, ding. Pollution is one of them. Pollution. Other. Oil. We're going to put oil and pollution as well. Yes, oil. Top 5 problems. Yes, sir. What was that? Overfishing. Ding, 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 ding. So now, we've got pollution and overfishing. 2, yes, we need 3 more. Yes. Global warming. Thank you so much. Climate change. Ding, ding, ding. So now, we've got pollution, overfishing, and climate change. Other 2 more. Acidification, yes, and that is part of climate change. Climate change is temperature rise, ocean acidification, sea level rise. Those are all part of climate change. Yes, very good. Yes. Oh, you guys are excellent. Yes, invasive species. Very good, invasive species. So now we've got pollution, overfishing, climate change, invasive species. 1 more. Fertilizer. That falls under pollution, right? That's nutrient pollution, yes, but especially right here, yes, very important. Medications, we're going to call that pollution too, yep. Ships, pollution, depending on what kind of ships, what the issue is. Let's see, do you want a hint? Seagrass beds would be appropriate, is one of these. Mangroves. Coral reefs is one of them. Yes, it is loss of critical habitats. Very good. You guys did great. So if you were to ask me in no specific order what my top 5 problems are, we're playing our little family feud game. It is pollution, overfishing, climate change, loss of critical habitats, and invasive species. But I don't want to talk about problems without saying, how do we fix them? Well, there's no one answer, and I think everybody here probably knows that. There is no one answer. We have to do a lot of things. We have to combat climate change. We need to reduce and prevent pollution. It's great that we dispose of our trash properly, but we have to stop producing so much of that trash. Sustainable fisheries, improved aquaculture. I also like to highlight some of the things at the bottom here. We have to cultivate high-level ocean champions. So we can all do a lot ourselves, but we also need leaders who care about the ocean, who recognize its value, who understand and want to prevent climate change. And we need to invest in education, outreach, and local programs. And that's one of the reasons I love what Zach and his group are doing, because we need to invest in educating people and letting them know things aren't hopeless. We actually know a lot of the things that we can do to make a difference. But it takes investment in getting that message out and making actions. And sometimes we think as individuals we can't make a difference. But as individuals, there are 2 places that you have a lot of power. One is as a constituent and who you vote for. And 2 is as a consumer, what you buy, what you eat, what you drive. As a consumer, you have a lot of power. So we all can do a lot. I heard somebody once say recently about climate change, one of the best things you can do about climate change is talk about it if you're concerned. If you have friends who don't believe in it, who don't know what to do, talk about it. So just by coming here, you're making a difference, by showing you're engaged and involved. So as I mentioned, one of the other things I do is I do write children's books, and I have to say it's been one of the most rewarding things I've done, is to work with kids and show them that not only science isn't hard, but it can be fun as well. And one of the things I did at the Florida Aquarium is I did an underwater reading where I laminated a couple pages from one of my books, and I got into the big tank, and I read. So where you guys are sitting would be the people at the aquarium, and I was inside the tank, and I had a mic in my mask, and so I read from the book, and I did Q&A, and the kids were so funny. So the first thing they always ask me is, because I read and then Q&A, and they always say, how come the shark isn't eating you? And I always say, because I taste terrible. And then they always ask me if this guy right there he's got that big long stick. Is that to poke the sharks? And I said, no, that's to poke the humans. And really, it's what he's doing there. Because so I'm standing and the acrylic wall is like right here. And sometimes the sharks and things, they want to come in between me and the wall, and I can't see them approaching, so I need to know to move back a little. And so he comes by and he literally pokes you, and you're like, okay, because then the shark is like, it was really funny. This one shark, while I was reading, just sat right over my head, and the kids were hysterical. Oh, and one kid said, it was great, he goes, why are you reading a book underwater? And I said, have you ever heard a book read underwater? And he said, no. And I said, well, that's why I'm reading it. One other thing, I don't think I have the picture here, but I did the same thing at the Georgia Aquarium. Anybody know what the Georgia Aquarium is famous for? Whale sharks, that's right. So I was kneeling on the bottom reading, and there was a safety diver behind me. And one of the whale sharks came over my head, and I knew she was over my head because it got dark. And so I'm like, yeah, whatever, I'm still reading. The safety diver told me, and people filmed it, she dove down, with her tail, smacked me on the top of my head. Now, I must have a really hard head because I was like, yeah, whatever, and I kept reading. Safety diver came over and grabbed me and was like, are you okay? Are you okay? I was like, I'm fine. And then later I thought, oh, geez, I should have pretended to be knocked out. People were filming it. It would have gone viral, and I would have sold tons of books. But then the other thing you have to think about is when that whale shark is swimming around that tank, she's not hitting things with her tail. She didn't want me to be the star of the attention, so she was jealous. So she literally did it on purpose. There is no... So I just want to mention, in addition to the Sex, Drugs, and Sea Slime book, I have two new books. One just came out, this Escape Galapagos, which is the first in a new middle grade adventure series. That just came out, and it's the beginning of a series called the Wonderlist Adventures. And I've integrated a lot of the fun animals and science into this great adventure in the Galapagos, and I brought some copies with me of that. But then, in about 3 weeks, maybe, I've been working on another book for a couple of years called Dangerous Earth, What We Wish We Knew About Volcanoes, Hurricanes, Climate Change, Earthquakes, and More. Instead of talking about everything we know, what I did is I went to the leaders in all those fields and I said, what do you wish you knew? So I'm going to be able to talk to you about what we don't know. Like if you were studying volcanoes, what is the one thing you wish you knew about volcanoes? And I'll just give you a hint with some of the things. It was really fascinating to do the research. So that book is about to come out. Volcanoes, almost all of the volcanologists said, I just want to see the plumbing. They wish they could see the pipes and chambers under the volcano, but there's that rocky overcoat, so they can't see it. But so that will be coming out in just a couple weeks. So with that, I'd like to open the floor up to questions. Yes, already. Yes. Yep. Oh, did you have a question? Yeah. Right. So that's a really good and difficult question. The idea is, so we all want to eat healthy and we want to support sustainable seafood. And so how do you kind of do both when, like with fish farming, there are some issues with fish farming in terms of antibiotics, waste. So the first thing I will say is that fish farming is improving dramatically. And for instance, they're creating closed systems now where you're not releasing the waste and you don't need as much antibiotic. So I would say fish farming is improving and look for it getting better and better. I think the health benefits of eating like farmed salmon is probably outweighs, as long as you're not eating a ton of it, the health, if there are any health, so that we haven't seen any, is probably better than eating, so in aquaculture, we're definitely getting better. I highly recommend the seafood watch cards that can tell you what good species are to eat, what we think are being well managed. For instance, mahi-mahi seems to be well managed and sustainable. As I mentioned, squid is sustainable. So there are lists. Monterey Bay Aquarium has a list. Carl Safina Center has a list. You can go and they'll tell you what are your best choices, what are your worst choices. Worst choices, typically, and I know I love shrimp too, but shrimp caught in the wild is not great because there's a lot of bycatch, a lot of things caught with the shrimp, and some of the shrimp farms are pretty ugly. But I will say, on the horizon, I think, are these closed systems for shrimp, which will be better. So I recommend going to some of those websites and looking at that. They will give you recommendations. So there are sustainable species, and I will tell you, I try and eat sustainably, but every once in a while, you know, I slack off that. But I do think fish, the benefits of eating farm salmon or even tilapia are well worth it as long as you don't go overboard. Other questions? Yes. In what area are the safest fish farms? Probably the areas where they're investing in innovative technology. So in the US, I would stay away from farm fish from China, probably, and Indonesia. But certainly in the US, we're doing probably a better job. Yeah? Right. So is there a chance that we can overfish? Certainly. And we've already seen that with certain species that have become what we call commercially extinct, where you can't fish them anymore. So my thinking in terms of commercial fishing in the sea is, I think there are some species that we can have a well-managed commercial fishery. But I think there are other species that I don't think we can commercially fish because they don't reproduce quickly enough. So I think we're going to have to eventually decide what species work and what species don't. I have to say, and I'm sure a lot of you love your grouper sandwiches, but I don't eat grouper because I don't think that's sustainable, but I'll eat mahi-mahi. So I think what's going to happen is that over time we're going to have to figure out what species we can commercially fish and which we just can't, and what species we can farm, and if doing it in an environmentally responsible manner. Yep. What is the best technology for cleaning up the ocean? You guys are asking hard questions. Well, it depends on what you're trying to clean up. Is there something specific? So plastic. So the best technology to never put it in there to begin with. Most of the plastic that ends up in the ocean is coming from land. A lot of people think it's coming from ships or oil rigs. No, it's coming in runoff from the land. And so we have to educate people not to be putting it, you know, dumping on the side of the road. I mean, we probably have all seen pictures of places in the world where they just throw it in rivers, right? We have to stop that first, okay? That also, hopefully, I think more and more, as people start not using plastics, it's not the not using it that's going to stop it, it's the suppliers who are going to stop making it. If we stop using it, they are going to stop making it. And that's the important point. It's not because, oh, I'm going to stop using straws. That's not what's going to clean up the ocean. But if I stop using them, somebody stops making them. And that's the important point. And there are ways to go out. I am very supportive of beach cleanups. Look, in fact, I've got the 4 ocean cleaning up the oceans. I got my little bracelet on. I'm all for that. There is this controversial big, I don't even remember what it's called, this boom thing that this kid wants to put out in the ocean. That I am not supportive of. One of the things we've already seen is that it actually kills wildlife, and it is not effective. You can't go out in the open ocean and clean up small plastics. You can do it to some extent, but it's got to be before it gets in the ocean or in the coastal zone is where we're going to be most effective. Yep. Other questions? Yes. Yeah. Uh-huh. So, yeah, so, I am a huge animal enthusiast, but I'm also sort of practical. And so I eat fish. I eat chicken. I try eat more vegetable plant-based diet, so I only eat those in smaller portions than I used to, so I'm trying to reduce that. But, you know, I guess personally, I see it as the food chain, and it's part of living on the planet that we hunt and we eat other animals. I am fully against capturing whales and dolphins in the wild. I'm completely against that. Animals, you know, big thinking animals, they're social and all that. But I also think it's not really realistic to think we're never going to eat fish. We got to feed the world. So, and more, I think fish farming is going to be one of the ways to do that. So, but I would say for the planet and for humanity, I think it's better if we have more of a plant-based diet than we do now. And I suspect we're moving in that direction because of climate change. I don't think we'll ever stop eating beef and red meat and whatever, but I think more and more people will start adding more plant-based food, and I think that's good. So the question is, what do I think? What do I think causes an organism to know it needs to mate? Or that's just instincts. You're born with that. I mean, it's the same way you know many things. Or when I was earlier, I showed some mating dances. Those mating dances, a lot of that is instinct. Some is learned. It's, you know, there's nature versus nurture, but a lot of that is nature. That is inherent in your cells, in your DNA. Yep. Over there, kind of neglected you guys. Yeah. Well, how much pollution comes from the big high rises? I don't think there's any more that comes from versus a neighborhood. I don't think there's one can be classified versus the other. It's human development in communities, and it depends on how they're handling their trash and their waste. It depends. Okay, so she's saying their sanitary systems. Again, it depends on how they're plumbed. You know, is their plumbing going to a municipal facility where it's all being treated? Then it's not going to be any different. But if it's not, then it is. One of the things that I have been involved with, and I'll just say this because you're asking this question, that one of the misunderstandings out there is about cruise ships. Most of the cruise ships, not all, but most of them now have advanced wastewater treatment systems on them that are better than municipal facilities. And you'll hear in the news, and they'll say, oh, this is an algal bloom or a fish kill, and then they'll say, oh, and by the way, this cruise ship happened to be right there. No. There are very strict policies and rules for cruise ships that most of them follow, and unless somebody is criminally doing something, which we know, especially one cruise line has been caught doing that, these new advanced water treatment systems, the water that's coming out still has to be discharged offshore, but it's essentially clean water. So the municipal facilities are actually worse than those systems, because part of the problem, and you all know this, is a lot of them are old. One of the big problems we have in this country is our infrastructure is old. Whether you're talking about water pipes, sewage, all of that, and roads, that's a huge issue that if we want to clean up the ocean, we need to clean that up. I mean, the sewage pipe is something that really worries me. Yes? Right. Right. Well, so the question is, what about chemical pollutions that we can't necessarily see? That is a big issue. Part of the issue there is the treatment plants aren't set up to clean them out. And so that is a big issue that needs to, at some point, we're going to have to work on. But, you know, you kind of have to set your priorities. And so I would rather see us work on nutrient pollution and sewage and things like that first and get that under control. And then, yeah, let's think about the chemicals too. So we have to, it's not one problem, and that makes it hard, right? Because it's all these things together. But, one of the things, it's always so kind of doom and gloom, but I will say, and this was one of the conclusions that I came away with my Dangerous Earth book with climate change and others, that, we were smart enough to develop these systems and to develop the use of fossil fuels. We are smart enough to fix the problem, but we just haven't applied ourselves and the investment to do it. It's not that we can't do it. We can fix these things. And so please, don't feel like this is the doom and gloom, all these problems in the ocean. We can fix them. We just need people like you to say the ocean is important and we need to fix them and we need to invest in them. So with that, I think, Zach, should we... Oh, one more? Yeah. Wait a minute, I recognize you. I'm just kidding. So the question is, how do you address invasive species? Well, there's a lot of different ways. So for instance, some of the invasive species have come from ballast water in tanks. And so one of the things, there's now laws about some places they have to have systems that clean the ballast water. Some places you can't exchange ballast water anywhere close to shore. So there's things with that. There's problems with, we think, with our favorite here in Florida, lionfish, that people were dumping their aquariums. And so that comes down to education, right? Educating people that you can't dump your aquariums in the ocean. You can't release certain fish in the ocean. So that part is education. There's also another issue of somebody goes out fishing and they've got their boat in one area and then they don't rinse it or anything and they go to another area and they carry the invasive species with them. So a lot of the with invasive species, I think, is education, making sure people understand what to do to prevent it. Yeah. Okay, so now I've heard this term before. Have I ever eaten sea vegetables? What is your definition of sea vegetable? So are you talking about algae or seaweeds? I've certainly had seaweed. Oh, so one of my favorite recent. Oh, so I don't know. I'm not sure, but I've eaten seaweed like kelp, which I actually really like kelp. The other thing I've had recently that I have become a big fan of, jellyfish. Anybody here eating jellyfish? I know it sounds disgusting, but no, the way they prepare it looks like clear, crispy noodles, and it soaks up whatever flavor. So I've had it in like Japanese sauce, and it's like a crispy, clear noodle. They're really good. If you ever have the opportunity, and there's invasive jellyfish, they're problematic, eat them. Eat them. I know, it was so funny because I took a picture of the last time I went, I ate some, and I took a picture, and they're in this lovely martini glass, but they had all this sauce on them, which made them taste great, but everybody's like, oh, they look so slimy, that's disgusting. And I said, no, that's not the jellyfish, that's the sauce.
Do we have any other questions for Ellen?
Oh,
Guys?
Yeah. Oh, I love Maine. Right. Right. Yeah, the question is about like harvesting baby eels or baby earthworms. Yeah, it is. In fact, they've tried to control that. I mean, I think one of the things we have to look at is, do we have to stop it altogether, or is there a very small quota? And I don't know the answer to that, but I think it has to be looked at. The idea of capturing baby eels before they're fully mature and can produce another generation seems unsustainable to me. But I'll be honest with you, I don't know the population dynamics, and that would have to be looked at. But it does sound very unsustainable to me. Yeah. Especially because with eels, there's so much about them we don't know. Once they leave the rivers and they go out into the ocean, don't even know where they go, and then they come back to give birth again. So there's a lot about those eels we don't even understand. Oh, another one. Oh, yeah. Okay, the first thing. So the first thing is vote. Vote, vote, vote. Get your friends to vote, your neighbors to vote. So vote. We also have to find ways to educate them better. But I will tell you, with climate change in particular, and this is, and I kind of address this in my upcoming book, the biggest chapter is on climate change, is the problem is a lot of people who don't believe in climate change, it's not because they're looking at the data. It's because they don't want to believe in it, or they're listening to somebody who's not an expert and they say, I believe this person no matter what they say. So it's hard to argue with them, oh no, you have to look at the data. And so one of the things we have to do is try to say, it's not, I don't believe in climate change because I say it. I believe in it because I look at the data and that's what it tells me. So it's not what one person says. But I do think, unfortunately, right now the biggest thing you can do is vote. Is we need to show, and that's, remember how I said we need to show people how important the ocean is? How important the whole planet is. The animals, the habitats. We need to let politicians know. And I will tell you, congressmen and senators, if you call their office, their staff almost always has to respond. It's part of a rule in their office. And so I would say don't ever hesitate to contact your state or your national representatives and let them know that you think the ocean is important, your coast is important, and that climate change is one of the biggest problems, serious problems we're facing today. Let them know that you think that. It's really important.
All righty, on that note, can you guys thank Ellen?
And should we?